Good evening, friends. We have seen earlier current concrete NDT practices in India with case studies as a full session. I thought we can break this session into different part containing every individual test. For example, this week we'll be seeing Rebound Hammer and how does it work, and what are the limitations and what are the advantages, and how we need to do the interpretation of the numbers what we get out of this test. Similarly, subsequent weeks, let us go ahead with ultrasonic pulse velocity and few other tests like durability issues, Hofstadter potential, chloride profile, and things like that. So I thought this will be the easier way to make people to understand that you will be able to have in-depth knowledge about this non-destructive testing, which is being done for long time since. Now this is what a rebound hammer looks like. What we are seeing now is a rider moving along with a graduated scale, and on the other side of it you have a graph where the manufacturer is giving you a graph to predict the compressive strength of the concrete with a variation of maybe about 6 to 10 MPa, depends upon the grade of concrete. But normally we do not use this test for predicting the compressive strength of the concrete. Basically, this is one of the oldest non-destructive testing, and which is still widely used. It was devised in the year 1948 by Ernst Smith. So therefore, this is also called a Smith hammer. Now, if you look at the cross section or inside, how does it function? Rebound hammer test is basically on the principle that the rebound of an elastic mass depends on the hardness of the surface against which the mass impinges. So it's the spring-loaded mass which has fixed amount of energy imparted to it by extending the spring to a fixed position. This is achieved by pressing the plunger against the surface of the concrete under test. Upon release, the mass rebounds from the plunger, still in contact with the concrete surface, and the distance traveled by the mass expressed as a percentage of the initial extension of the spring, which is called a rebound number. This number indicates by the rider moving along the graduated scale. So this is the basic principle, which is very simple, how this rebound hammer works. Basically, it is a very simple handheld device which is used very widely, as I said earlier. It measures the hardness of the concrete surface through a rebound of the spring-loaded mass. Rebound number measured on the graduated scale, given as a rebound number, as we have seen the earlier slide. Larger the rebound number, harder the surface concrete. Please do remember, this is a qualitative test and this is not a quantitative test. So we cannot predict, generally people tend to predict the compressive strength of the concrete, which is not advisable at all because there are a lot of limitations on that. Now on field, this is being done on a transmission tower foundation for an RC chimney. Commercial building of an RC roof slab. Please do remember that when you wanted to do on a concrete which is already plastered, we need to remove the rendering, which is the form of a plastering, because our intention is to find the surface hardness of the concrete, not on the plaster. So we need to chip off about 100 by 100 and then do the grinding and then start taking the readings from the parent concrete. This is another structure, which is a marine structure of an RC deck slab. Bottom is being done with rebound hammer, and it's on a bridge RC deck bottom portion. And in airport runways, normally airport runway is being done with a BT pavement, and that needs to be topping, that needs to be removed and expose the concrete and then do this rebound hammer test on the surface of the parent concrete. When you get a number, the rebound number, which is going to be more than 40, it indicates that the quality of the concrete, the cover region is very good. But between 30 to 40, it's good. 20 to 30 satisfactory, less than 20 poor concrete, or even corrosion could have taken place in the concrete when the rebar gets corroded, or as all of us know that it expands, and as it expands, it pushes the cover concrete, we hit the rebound number right over that particular region, we will not get value and we get very low value. Now coming to the limitations of this test, since it depends upon completely on the smoothness of the surface, so how good you prepare the surface, we can do the interpretation little more confidence. If the surface preparation is not done properly, if you don't make the surface smooth, then you may get a different number, which may not be the true value of the surface hardness of the concrete. This also varies with respect to size, shape, and rigidity of the specimen as well. Because if the concrete quality or concrete strength is going to be very low, let's say it's less than 7 MPa, and it is very difficult to do test, Rebound Hammer test on this, because the energy absorbed by the concrete is related to both to its strength and its stiffness. So it is a combination of strength and stiffness that governs the rebound number. So it is going to be very low, and where the stiffness or the strength will be very low in such a way that you will not get any rebound number, as the energy get dissipated at the interface of the plunger and the concrete. It is also affected by degree of saturation and surface moisture. If it is going to be high saturated concrete and surface moisture is very high, and obviously you will get a lower number. And type and size and content of aggregate. If you are going to use a 40 millimeter aggregate, if you happen to hit the aggregate directly, you get a very high number, and it may not give the representative rebound number of the concrete, but it would give the representative number of the aggregate. So also, you should look at the content of aggregate, the coarse and fine aggregate content. We always design on the mixed design. If you get more of coarse aggregate, and then you get a higher number, which may not be representative of this concrete. Of course, type of cement and type of molds also matters a lot. The last but not the least, a concrete structure which is being serving already, if the concrete cover would have got carbonated by many reasons, because there is no protective coating on it, and the carbon dioxide gets diffused into the cover concrete, and the carbonation takes place. Once the carbonation takes place, the pH value of the concrete gets reduced. Once it gets reduced, the concrete becomes harder. When it's become harder, when you hit a rebound number, then you get a very high rebound number from this rebound hammer test, but that may not be a correct indicating number of this cover concrete. The increased number would have been because of the carbonation taking place. When it comes to correlation, although the manufacturer is recommending a correlation chart which is available on the instrument itself, but these tests performed for a specific specimens. So on site, we will not be able to carry forward the same correlation graph for the concrete members which we are testing at site. So we need to be very careful while converting it, unless or else we have got the data available of cubes of that particular aggregates and that particular site, we will not be able to really do a proper correlation of strength with this number. So it is always better use the rebound hammer only for a quality indication, definitely not for predicting the compressive strength of the concrete. Now, generally in a site, we go for different tests. We correlate without those tests. Rebound hammer, UPV, core extraction. This would give you the exact compressive strength of the concrete. Hostile potential test and powder sample extracted from the deck slab for durability issues. When you want to conclude it, you have to summarize all the values of the different tests which are done in such a way that when you want to talk about or infer for the rebound hammer, normally the inference can be done in this following manner. The quality of the concrete in the near surface applying through rebound hammer test are between good to very good based on that number. In another site, I suggest the bridge, where the testing of about 200 numbers of ultrasonic, 200 numbers of rebound hammer on abutment, pier, many other places. When you wanted to refer this based on the number. Look at this side now. The average rebound number value was 25. So we can infer quality of the concrete in the near surface is good with respect to PS. Whereas when you come to a pair cap, the rebound hammer value is 31. Still it falls the gap of between 30 to 40. So the quality of the concrete in the near surface is good. But when you wanted to refer the deck slab, where the average rebound hammer value is only 22, so we can infer the quality of concrete in the near surface is satisfactory. So that's how we can make it. We will not be able to quantify any FCK value of the concrete. So overall, while the rebound hammer test is useful within the limited scope, the test is not a strength test and you should not claim a replacement of compression test for using this rebound hammer. So that we must be very, very clear. In fact, even during 1965 and 67, an international survey on the use of rebound hammer was carried out by Raylam. Majority of those who spoke were against the use of rebound hammer in acceptance testing as far as the predicting the compressive strength is concerned. The consensus was that the spin rebound hammer is very useful in checking uniformity of concrete and comparing one concrete against another, but it can only be used as a rough indication of concrete strength in absolute terms. This is what they inferred, and Ryland finally concluded that you cannot take it as a clear-cut number where you can use these data for doing the analysis in terms of repair and rehabilitation. So I'll summarize it. This is a very widely used test and very long standing test. From 1940 it has been used, but it has got a few limitations and it has got few advantages. The advantages will be able to know the cover concrete quality or concrete quality, surface concrete quality. So it's only the qualitative test, it is not a quantitative test. With this, I conclude this session. Let's meet next week to discuss on ultrasonic pulse velocity. Thank you so much.